all of our money together in these beds, and then we'll play with the I mean, I found into the business. I can't.
Start working on this worksheet. We're going to go over it real quick. There will be a quiz here in a few minutes. Over the ideas on the worksheet and page 181 and 189. Is that right?
Something like that.
The homework from a long time ago. So make sure you have that homework out to be checked. Should have done it a long time ago. Most of you probably. So have it out. I'll come around and check it here in just a couple of minutes. All right, on this worksheet, real quick. I know we're not going to have time. The same amount of time that I wanted to take on this. So to make sure you got time to do the quiz and everything else, what I want you to do is just follow along. One side says 4-1, the other side says 4-2. We're going to start on the 4-1 side. We're going to go around the room, just down the rows. Each person's going to give me an answer, write it down, so on and so on. All right? So the first one, I know the first 6 here says use a protractor. I keep forgetting to explain this. Don't use a protractor, just use your head and make your best guess. All right, I think I told you that on the homework on the other pages. So starting with number 1, Austin, what kind of triangle? Acute, equiangular, obtuse, or right? Equiangular. Could you name it something else? What kind of triangle is it also? Acute. Right? You could also call it an acute. Equiangular is probably a better name because it gives us more information. So equiangular for number 1. Josh, number 2, what kind?
Obtuse.
Obtuse. Everybody agree with obtuse? Now watch. Remember, we talked about this earlier this year. If you're not sure if an angle is a right angle or not, you can check it. If I can do this. Try to line that corner up, because that corner right there should be what kind of angle? Should be a right angle, shouldn't it? You line it up in the corner, match up one of the sides of the angle with one of the sides of the paper. The other side, you can see it comes out bigger than the 90 degrees. Everybody tell what I'm doing there? Just lay it right on that angle. That way you don't need a protractor, you could just check it. So that tells us that angle's obtuse. So it's an obtuse triangle. Number 3. Nick, what kind for number 3? Acute. Everybody agree with that? All right, on number 3, take the corner of another piece of paper. One of those angles looks like it might be a right angle. Everybody see that? Take the corner of the paper, stick it in there, see if that is a right angle.
Because I have a protractor on me right now.
Look at mine, Josh. Does it look like it's matching up pretty well with the corner of that paper?
Mine does.
So what kind of angle do you think that is? It's a right angle. So what kind of triangle is that? The right triangle.
Right here is 89.
You measure right.
Number 4. Brighton, what kind did you get for number 4? Equiangular. Everybody agree with that?
Yeah.
I put acute.
Acute.
I got equal. I put a dot.
What would to be an equiangular? What has to be true?
All 3 sides acute.
All 3 angles are the same, and all 3 sides are the same, right? So is it equiangular? So what's the best name for number 4? Acute. Number 5, Brian, what kind of number 5?
Obtuse.
Obtuse. Everybody agree with that? Anybody not think it might have been a right triangle?
No.
It's not.
How could we tell? Take that piece of paper and stick it in there again. And it does look like that angle is bigger than the 90-degree angle, right? So obtuse. And Faith, number 6.
Acute.
Acute. Everybody agree with that? Anybody put equiangular on number 6? Don't be afraid to. How come it's not equiangular? All the sides aren't the same, so all the angles can't be the same. Number 7. When you're doing number 7, remember when you're naming a triangle, use, let me get to this real quick. Use the triangle symbol and 3 letters. We named triangles earlier this year, so use that triangle symbol and 3 letters. A right triangle for number 7. Where do we leave off? Marissa, name me a right triangle.
Triangle
EAB. Did Marissa name it in the correct order?
Yeah.
How come?
Because she went around the time.
That's true.
Can you do it in any
Triangle you can do in any order, right? Does it matter?
Well.
So if you didn't write down triangle EAB, what else could you have written?
BAE.
BAE, ABE, any of those would have worked. Number 8, an isosceles triangle. Before I have Brittany tell me an isosceles triangle, somebody tell me what an isosceles is, right? What's an isosceles triangle?
An isosceles is a triangle that has at least 2 congruent sides.
2 congruent sides. So, Brittany, find me a triangle in that picture that has at least 2 sides congruent. Brittany. Yeah, we changed your name, Brittany. to Brittany. Say it again.
Triangle
EBC. Look at EBC. Is 2 of those sides equal? DBC. Everybody agree with that one?
Yeah.
Now, are there other triangles in that picture that have 2 sides the same?
Yeah.
Yeah, you could go through and find those. Number 9, scaling. Before we do scaling, all right, Brighton, what's a scaling?
On the sides of the congruent.
No sides congruent. So, Mr. Hoblet, give me one with no sides congruent. Oops.
Triangle EAB.
Don't look at that. Triangle EAB, is that what you said?
Yeah.
Hold on now, that's the same as what we named up here. Is that right?
Maybe.
Yeah. So not only is triangle EAB a right triangle, but it's also a scalene triangle. Number 10, obtuse triangle. An obtuse triangle. What's an obtuse triangle, anybody?
Triangle
Has at least one obtuse angle.
One obtuse, at least, hold on.
Only one obtuse angle.
Has one obtuse angle, right? Can't have more than one because then it wouldn't be a triangle. All right, Weston, give me an obtuse triangle in that picture.
BDE.
Say it one more time.
BDE.
BDE, everybody agree with that?
Triangle fed.
Everybody agree with that? Yep.
Number 9,
Uh-huh.
triangle DBA word.
DB.
That's right. Thank you.
Uh,
That work?
Is that in the triangle?
Draw that line.
You could connect that, I guess, and
Oh.
I,
As far as the picture goes, no, it's
No,
not.
that line is
the,
horrible.
the bad thing is that we don't know anything about AD, so AD might be the same as BD, but we're not sure.
That's right.
Number 11. Problem 11, watch carefully. They tell us triangle ABC is equilateral. What's it mean for a triangle to be equilateral?
Sides angles.
So I know all these angles are the same. What are all those angles?
30 degrees.
Close.
60.
They're all 60 degrees, and we know all 3 of these sides have to be the same. They tell us, I guess I should name it here. This is A up here, B here, C here. Did I put them in the right spots?
Yeah.
It doesn't make any difference, does it? So if you drew your triangle different, you put A down here, B up here, C up here, it's still going to be the same thing. Now, not for all triangles will that work, but for this one it does. AB, 3x. So I say -2.
Yes.
and BC is 2x plus 4. That's this down here. Now, a lot of people get confused on this one, so watch carefully. CA is x plus 10, and I bet, even though as intelligent as you guys are, I bet somebody gives me the wrong answer here. What equation can I set up from that? Do we want to let Brighton
I think I
mess it up?
Go Brighton.
All right, Brighton.
x plus 10 equals 2x plus 4.
He hasn't raised it.
Does anybody know what equation did I think? Some of you might try to do on that. What would you maybe try to do with these three
Combine the
sides?
x's and like add all the things and then set it equal to 180.
Equal to 180. How come that doesn't work?
Because it's on the sides, not
These are the sides, not the angles. Now, if you're dealing with perimeter, then you'd want to add them all up. If they told us the perimeter is 50 or whatever, then this side plus this side plus this side should equal 50. Don't add up the sides to equal 180 because angles add up to equal 180, not the sides. The sides don't have anything to do with 180. All right? So make sure you don't mess that up. Now, how come Brighton set this one equal to that one? Does it matter which two he picked out? No, so you could have set up this equation. You could have set up this 3x minus 2 equal to x plus 10. You could have set up the 3x minus 2 equal to 2x plus 4. Any of those would have worked when you solve it. Subtract 4 on both sides. So what's x equal? Is that our answer?
Part of it.
Part of it. What else did they ask us to find?
Find the angle and measure of each side.
Find the measure of each side. Where's the easiest one?
X plus 10.
How long is x plus 10?
16.
Please be sure it said find the measure of each side. Do I just stop there then?
No. In this case, you can.
Even though I know that what's true about the other two sides.
They're the same.
They're the same, but still find those answers and write them in. All right? Make sure you still find them and write them in. And there'll be one like that on the quiz where you need to, it's going to ask you to find these two angles. Well, if they end up being the same, you still got to find both angles. So still put down both answers. Number 12. Watch carefully on this one because we haven't talked about this a whole lot yet. An isosceles triangle. If this triangle is isosceles, some point, hopefully in the past, you've learned this. If you have an isosceles triangle, these two sides that are congruent, anybody know what they're called? Legs. Anybody know what this third side's called? A base. Good. Anybody know what these two angles right here are called?
Feet.
That's a good guess. Base. The base angles. All right? They're around the base, so they're base angles. This angle up top, it doesn't have to be up top, but the angle that's between the two legs is called the vertex angle. They always have to tell you one of those pieces of information anytime they give you an isosceles triangle. That way you know how to draw it. All right? So when I go to label this, what letter goes here? D, because they told us D was the vertex angle. What letter goes here? Does it matter if it's E or F? No, it makes no difference. What mattered is they told us that was the vertex angle, so when I drew it, it should be that way. Then they tell us DE is x plus 7. They tell us that DF is 3x minus 1. Is that right? And they tell us that EF is 2x plus 5. What equation can I set up on this one? How come?
Because they equal.
How do you know that?
You got the little there.
These are the, if it's isosceles, those are the two legs. That's your vertex angle. So this has to be a leg. That has to be a leg. How come, could you set up this one equals this one down here?
No.
Doesn't work on this one. Worked on the equilateral or equiangular triangle, but not on this one. Solve this. 7 equals 2x minus 1. Add 1 to both sides. 2x equals 8. What's x equal? Is that our answer? It's part of it. What else do we still have to do? Plug it in. Which place is easiest? Plug it in. So how long is that side? How long is this side over here then? About this side, is it 11 also? You gotta plug it in, right? 2 times 4 plus 5. I think Faith said it's 13. Again, make sure you give all 4 answers.
That's weird that that bottom leg is longer than the 2 though.
Now, again, Brian's saying it's weird. It's only weird because of what?
The picture.
Because of the way I drew it. Did they tell me to draw it that way with the 2 legs being longer than the base? No. So don't go by when you draw your picture, because if you draw an isosceles triangle, 99.9% of the time, that's what you're going to draw, what I just drew, and not something like that maybe, where those are your 2 legs, just because it's easier to draw it the first way. All right, so don't go by what your picture is and say, well, that can't be right because this side can't be longer than that side. Well, it's only longer than that side because of the way we drew our picture. All right, flip over to the other side. We're going to skip those bottom 2. On the other side, we'll do just a couple of these. Somebody pick me something a number that you want me to figure out for you. 2. Number 2. Brittany must have been watching earlier. Paying attention, I guess. That picture doesn't look all that great. What's these little arcs in here tell us?
They are.
Those are equal. This is 146. So if I draw this off, just look at the triangle. These 2 are equal. This is 146. How can I find this angle and then this angle? 180 minus 146. What's that give us? Since these 2 have to be congruent, I take that 34, divide by 2. What do I get? Is that my answer?
Yes.
What they ask us to find?
Find the seeds.
Find the missing angle measures.
Yeah.
So is that it? The other one is how much? We want to find both of them. Again, make sure you find all answers, not just because they're the same. Don't think that I know that. You got to tell me that. Hey, those 2 are the same. All right, pick me another one.
15.
15.
I had to search for that.
Now my picture's probably not going to look anything like it should, so follow along carefully. 63. Oops.
What?
Um,
Whoa, what happened to straight
and
line? Dude, use that 3.
is that it? First thing you're going to do, when you're given a problem like this, and we'll do one more after this, so maybe we'll do another one sort of like this, don't jump in here and try to find angle 1 right away, or try to find angle 2.
Why do you find angle 1 to get to the answer?
All right. Okay, so this time it sort of works out that you find angle 1, then it's going to lead you to angle 2. But don't necessarily think that, hey, if I find that angle, then it's going to lead me to that one, then the next one, because that's not going to work out. So anytime you have a picture that's got a whole bunch of missing angles in it, go through and find all the angles that you know. Then worry about answering the questions. All right? Don't just look at them and say, all right, I got to find 1, because they may make angle 1 the hardest one in the whole picture to find, and then you'll be lost after that. So if I split off, let's do the big triangle first. If I split off that big triangle, I know that's 90, I know that's 63. Can I find this angle down here? 90 plus 63 is what, 153? Then what do I do with that? Subtract it from 180. Notice again, we've been talking about this all year long. I split off my picture and just look at the big triangle instead of looking at all three triangles there together. What is 180 minus 153? 27? So that means this angle right here is 27 degrees. I think that was one of our answers, right? If I look at that, can I now find this angle up here? Yeah, if I split this off, and I know we really don't have to go through this. I'm just going through some extra stuff here. Add those two together, subtract from 180, so 90 plus 27. What's that, 117? Is that right? Subtract that from 180. What's that give us? 63. Now if I look over here to angle 1, a couple different ways I could find angle 1.
90 minus 63.
You could just do 90 minus 63. If this angle's 63, subtract 90 minus 63, and that should leave you at that. You could look at this whole triangle over here, 90 plus 63, and find that out. Well, you just did all of that right here. What is this angle then? 27. So angle 1 there is 27. I think that gives us both of them that they asked us for it. Next question. No others, just take the quiz.
Wait, can we go over how to find the outside angles again? The exterior one?
Yep, find me one that's got exterior angle.
Number 6.
It's number 6.
Number 15 was super easy.
Dude, just got always ask the first and last question. No one
And
asked
then
the
you
first
ask
question.
everyone in between.
Yes,
Yeah.
but just add the buns to the second.
Brandon, I want you to sit there and think about
No, I'll die again.
I had again. I didn't watch it.
They were showing
that's
my
right.
girl has like a disease. I had
She had
disease.
a stoma on her stomach. She had a stoma.
Spider-Man.
Spider-Man. No, she had a stoma on her stomach, and Brandon had never seen one. And he was like,
Oh, that one.
Yeah, he's like, no, I really don't get it. Thank you. Of course.
All right, watch. Last one before this quiz. When you see a picture like this, do not just go in and try to find the angles that they're asking you to find. All right? And we could go through, and these aren't real hard to find, but there's going to be a lot of pictures, a lot of diagrams where you need to do this other stuff. Did they ask us to find this angle? Can we find that angle?
Yeah.
Am I going to take off points because you find that angle? No, if it helps you, then find everything in here. So I'm going to go ahead and throw some other numbers in here. They did 2 and 3, so let's go. Did I miss a number?
Yeah, 1.
1 is outside here.
Yeah.
Yeah. This is number 1 out here. Let's put 4 there, 5 here, 6 there, 7 there. Is that all of them? So we can find all of those. Now, we wanted to go over how to find this exterior angle. The 2 remote interior angles, if you just look at this triangle, these 2 remote interior angles are related how to this exterior angle out here?
There.
Sorta. What do you do with those 2? Add them up, and it should equal this. So what's 70 plus 55? So that angle outside there is 125. Now, could we have added these 2 together and found angle 4? Yeah, because 3 angles of a triangle should add up to be 180. So we could do 125 subtracted from 180. What is 125 subtracted from 180? 55, that'd be this angle in here. How would you find this angle, angle 5?
You would find 180 minus 55.
Those two have to add up to be 180, or you could have done 70 plus 55, like I heard somebody say, because that's an exterior angle for these two remote interior angles. What is angle 5 then? 125. What's angle 6? 125. How would you find angle 2? Vertical to that one. So it's 55. How could you find angle 3? This.
Because minus 55.
All right, so these two together should add up to be this exterior angle, and this is really the only way we can find angle 3. These two together should add up to be that. Well, 150 minus 55, what is that, 95? So what's angle 3 have to be? 95. So what kind of triangle is this triangle here before we go on? An obtuse triangle. How can we find angle 7? So what is 180 minus 30? These two should add up to be a straight angle, which is 180. So that is 30. Now I said that that was the only way to find that one. That was wrong, because could we have found this angle first and then added this one and this one together and subtracted from 180 to get that one? Yeah. Have we found every angle in that picture now? Did it take very long to find every angle? Do that, go through, find every single angle, then worry about, and I know sometimes, and on this quiz is a perfect example, there's going to be a problem on here where if you go through and find every angle, you probably took about 10 times longer than you actually had to find the answer, because the answer was real easy. But on a lot of problems, go through and find every angle, then worry about answering the questions. All right, you need to have out a clean sheet of paper. You can tear it in half if you want, and share with your neighbor. Otherwise, there should be no talking from this. Hit the wrong button. Go ahead. Should be no more talking. This is question 1. Don't worry about this up here. That means nothing. Just told me something. That's question 1, question 2, question 3. Got about 5 minutes to do this. Shouldn't take any longer than that. When you get finished, bring it up like right here on this blue chair. And get your notes out so you can start copying down the notes that I'm going to put up on the slide or up on the screen. Sorry, I'm going to turn off the lights because you probably can't see that very well, can you? Is that what you were saying, Emma?
Yeah.
I just walked the wrong direction. It takes me a second sometimes to really know what I'm doing. Plus, it doesn't affect me because I still can't see it. to record that, Noah.
Josh heard it calling us.
Today is the 11th, is that right? Go ahead and start copying this down, copy real quickly.
We did. Yeah, probably won't. I forgot all about that. Well, no, our second one was one.
Yeah, because Josh, somebody calls and then you're.
Mine was
and
Nick.
it dies.
My internet doesn't do that anymore, Friday.
All right, what we're going to do, identify and name congruent triangles. Please remember how to name a triangle. Triangle symbol out front, 3 letters. It's always the corners or the vertices of the triangle. We're going to name congruent triangles. Special way you got to, if 2 triangles are congruent to each other, special way you got to name them. We're going to talk about that. And also use congruent triangles to solve problems. Example. If I give you these 2 triangles, and I tell you that they're congruent to each other, and I tell you this angle right here is 68 degrees. What's this angle right here have to be, do you think?
68.
68 degrees. What's going to happen if 2 triangles are congruent? Then the angles that match up have to be equal to each other, and the sides that match up have to be equal to each other. So if I told you this side right here was 15 centimeters, what's this side over here got to be? 15 centimeters.
That means they're
All right? If 2 triangles are congruent, then all the parts that match up have to be congruent to each other, and that's the other thing that we're going to talk about. All right, definition, just write down this part. We were going to do something else, but since we're short on time, don't worry about this top thing here. We're not going to do it. You notice down here at the bottom, don't write that either. That's a note to me. I was going to use a bag to show you these different triangles, but definition of congruent triangles, I'm going to give you the definition. This probably isn't the definition that the book gives you, but this is the one that we're going to use. Got to think how I want to write it, trying to keep it as short as possible.
Triangles with congruent angles.
Triangles where all corresponding, what's it mean to be corresponding?
Angles and
What's corresponding mean? Things that
together.
match up together. All corresponding angles are the same measure and corresponding sides are the same lengths. So again, you've got 2 triangles. For these 2 triangles to be congruent, all corresponding sides have to match up and be the same.
But they can't they be congruent and one be smaller?
It's similar.
Now, that's, if all the sides are congruent, then the 2 triangles are going to be congruent. What you're saying, Brian, is if I did this, if I had this triangle, and then I had this triangle, and if I knew that this angle was a right angle, that angle was a right angle, this angle was 60 degrees, this angle was 30, this one was 60, this one was 30, Well, are those two triangles gonna be congruent to each other?
Proportional.
No, they're proportional to each other, and that's something we're gonna learn later on, right? They're proportional to each other, they're similar to each other, but they're not necessarily congruent. Up here, if this is a right angle, or if these two triangles are congruent, that's a right angle. This is 60 degrees, 60, 30, 30. Those two triangles are congruent to each other. These two triangles, not congruent to each other, they're similar to each other, and that's something we're gonna learn later on. But to be congruent, all the corresponding sides have to match up and be the same. All the corresponding angles have to match up and be the same. And we probably won't get to it now before exams, since we had those days off, we were supposed to, but we're actually going to learn shorter ways to show that things are congruent to each other, shorter than this. But for now, this is all we know. All right, don't write this down, but you might want to draw these two triangles down there so that as I go over this stuff, this is the same thing. Two triangles are congruent if and only if. This is the book's definition. I made it a little longer because it's confusing the way they write it. Their corresponding parts are congruent. So when we say that the corresponding parts in this triangle is corresponding parts in that triangle, remember what you got to do is match them up. What transformation would I have to do to this triangle to get it to match up to that triangle?
Slide.
A slide, a translation. Little review for the exam here. Other times you may have two triangles maybe that look like this. Can I do a slide to get those to match up? No, you'd have to do what would it be?
Rotation.
A rotation or a turn. All right, and that's part of what we're going to cover today too. So if these two triangles are congruent, segment AB here has to be congruent to what? FD. So mark those two congruent to each other. Segment AC has to be congruent to which segment? FE. Now can I just mark them like that? No, you want to put two tick marks to show that these are different than the other two. And segment BC has to be congruent to what? DE. I'm going to be lazy. Instead of putting three tick marks, put little circles on that. As long as they match up, they have the same markings on them, and that means that they are equal or congruent to each other. Angle A here. What's angle A have to be congruent to?
Angle F.
How about angle B?
Angle D.
Now, can I mark those that way?
No.
Now, put maybe a little tick mark on them or something, just to show that these two angles are congruent, these two are congruent, and angle C has to be congruent to what? I know my drawings aren't very good, but hopefully you can figure out my markings.
This looks like witchcraft.
Now, when we go to name these two triangles, you want to say that you want to write out a congruency statement. Say this triangle is congruent to this triangle. Somebody name this first triangle for me. ABC. When you name the first triangle, it makes no difference how you name it. Faith named it ABC. Josh might name it CAB. It doesn't make any difference. What does matter is when you name the second triangle. When you're writing the congruency statement here, you've got to make sure that your letters in this triangle match up to the ones in the other. What did A match up to in the other triangle? F. So if A came first, F has to come first. Does that make sense? That's sort of one of the key things that we're learning today. You've got to match up this triangle, this one. And that's if we take it and slide it over here, the things that correspond to each other, things that lay over top of each other, just like with corresponding angles with the parallel lines, things that laid over top of each other are the things that are going to correspond. So A matches up to F. What's B match up to? D. And what's C match up to? Somebody name that first triangle a different way for me.
CBA.
CBA. How would the second triangle have to be named?
EDF.
Say it again.
EDF.
EDF. Just make sure that you match up corresponding things when you're naming it.
I could do cab.
And that's what we just covered. When you name, the way you write the congruency statement, it's very important. You gotta make sure you match everything up. If you don't match it up, then the way you named it's gonna be wrong. All right, write these three things down. Don't do it.
Write them down. He easily said.
You obviously know what it means.
You might put a triangle with each one of these. We've dealt with these three properties many, many times throughout the year. All this one, going over these three properties, is going to tell us is that not only do they work for algebra, we talked about that at the beginning of the year, we also talked about these three properties work for segments, and these three properties work for angles. Well, these three properties also work for triangles. So, properties also work with triangles. We've dealt with these three properties over and over and over again. Actually, there was another one that I don't have on here. What's the other property that went along with all these? Symmetric, transitive, reflexive. Hopefully you'll remember it before the exam.
I don't remember it.
I'm gonna study before the exam.
Reflexive properties. Anybody remember what reflexive property said?
Yeah.
This is one that you need to remember now. I know we haven't used it a whole lot.
Reflecting across the
It's not like
That's a reflection with a C8 or CT in there instead of a X. A equals A. Anything equals itself. So what it says about triangles, triangle QRT has to be congruent to triangle what? QRT. That's sort of common sense, right?
Was it the substitution property that
Substitution was the other one.
Bam!
Genius, Josh. Super genius.
Rob taught me well.
All right, symmetric properties. Anybody remember what symmetric property does? You got this equals this. What's it do? It just switches them. Switches sides. So in this one, it's going to say if triangle ABC is congruent to triangle XYZ, then what do we know? Triangle XYZ is congruent to triangle ABC. Just switches it around. For triangles, you won't use those two very often. Now, as we're dealing with triangles, we'll use reflexive property a lot to say something like this. Segment AB is congruent to segment what? AB. We'll use that a lot as we're dealing with triangles throughout this. But as far as just saying triangle QRT is congruent to triangle QRT, we don't use that very often. Transitive properties. Anybody remember what transitive is? It's like substitution. Let's do triangle. We did ABC, so let's go with DEF is congruent to triangle. I think of my alphabet here. FGHI and triangle. How's this next part have to start?
With a GHI.
GHI is congruent to triangle HI, what, JKL? Then what do we know?
Is it JKL? No, it's DEF first.
Alright, so triangle DEF is congruent to triangle what? JKL. So if DEF is congruent to GHI, GHI is congruent to something else, then the first one and the last one have to be congruent. That's the transitive property. Again, we don't use that real often. Hopefully if you could just remember, if I give you 3 triangles, and I tell you all 3 of those triangles are congruent, and this angle's 50 degrees, what do we know about this angle then? 50, and how about this one? 50. Alright? So that, you know, they say this one's congruent to this one's congruent to something else, you can just use that to, like, use substitution to move it over to that other triangle. Alright, write this down real quick. Congruency transformations. This is just going back over the stuff that we did earlier this year. Slide, flip, and a turn. Which transformation is not up there? Dilation. How come dilation is not up there?
Because it's proportional.
Alright, because that's when you make something bigger or smaller. We're not actually changing the shape here, we just want to match them up. We want to show that they are congruent to each other. What's another name for a slide?
Translation.
Translation. Another name for a flip? Reflection. Another name for a turn?
Rotation.
Rotation. Very good. So all they're doing, they're just telling you, if you have these 2 triangles, and you know that they're congruent, we'll put some letters on them, A, B, C, D, E, F, doesn't matter where the letters are. If those 2 triangles are congruent, A has to be congruent, angle A has to be congruent to what angle in the other? F. B has to be congruent to E, and C has to be congruent to D. Now if I give you something like this, triangle MNO is congruent to triangle PQS. Angle M would have to be congruent to which angle? Angle P. Does everybody see how you can just get that from the names without actually ever seeing the triangles? How about segment MO? A little tougher here. Segment MO has to be congruent to which segment?
Well, I
Yes.
thought you said the order of the letters don't matter. But how do you know if they're congruent?
If they're congruent, it matters. If you're just naming one triangle, then the order doesn't make any difference. But when you go to say that these 2 triangles are congruent, so if I said triangle ABC, you can name this first triangle any way you want. But when you name the second triangle, you got to make sure that your letters match up. So A matches up to what over there? B matches up to
D. Or, oh, B mixes up to E.
and then C matches up to, so you have to make sure that they match up correctly. Then once you know that, you can just look here and say segment BC has to be the same as what segment in this triangle? ED. So you could just use the names to pick out those segments that are congruent and the angles that are congruent. So it's very important. First triangle, doesn't matter how you name it. You can name it in any order. Second triangle, you got to go by how you name the first one. And that's where this stuff comes in. What would I have to do to this triangle to get it to match up to that one? Which of these transformations would I have to do to match it up to that one over there? You'd have to flip it over, reflect it. All right? Come on. It didn't take, did it? I want that. That's your assignment.